Here is the next example. Here also we are doing the DC analysis of MOSFET. This is an N-channel MOSFET. How do we know? That arrow indicates if the arrow is going outside, then that's N-channel. If the arrow is going in, that's a P-channel. So this is gate. Another important point we need to know, Ig is always 0 because there is an insulation between these two plates, and then there won't be any current entering into the drain side or source side. Okay. So here is my source. By the way, that arrow is always on the source side. Okay, and here is my drain. Now there are two types of operations. One is triode mode of operation, another one is saturation mode of operation. So we always assume this transistor is working in saturation mode and start solving, and then we'll prove our assumption is right. If our assumption is wrong, then we'll move back to the triode mode and solve for it. So the triode mode has a different ID equation and saturation mode has different ID equation. ID is nothing but the current passing through the drain. By the way, ID is always equal to IS in the MOSFET. That is true either N-channel MOSFET or P-channel MOSFET. So in saturation mode of operation, this is the current equation. ID equal to half Kn prime width over length VGS minus VT whole square. So he gave us the Kn prime value, width over length value, VT value. I don't know VGS. So we'll find VGS. What is VGS? VG minus VS. Now I don't know VS value. We'll figure it out that in a second. But I know VG. What is VG here? What is the voltage at this point? Since there is no current passing through this 25 kilo ohm, okay, there won't be any voltage drop. So can I say my VG is nothing but 5 volt? VS, I don't know. So I'm going to keep 5 minus VS. It's look like S, but that's not S, that is number 5. So 5 minus VS. Now I'm going to substitute 5 minus VS here. Instead of VS, can we find something else? So here is my VS. I know this current is ID. So I can say my VS is nothing but 2K times ID. If I take ID in milliamperes, so it's a 2 ID. ID is in milliampere. Is in milliampere. Okay. Now milliampere. Now ID equal to half Kn prime is 1. See, that is in milli. So I'm taking milliampere, so I can ignore that M. And width over length is given as 0.5. And VGS is nothing but VG minus VS. So 5 minus VS is nothing but 2ID minus VT is nothing but 1 whole square. So we'll end up with a quadratic equation here. So it's going to be 4ID equal to 4 minus 2ID whole square. So if we expand this, we'll end up with 4ID square minus 20ID plus 16 equal to 0. Okay, or you can say ID square minus 5ID plus 4 equal to 0. Okay, it's a quadratic equation. You can find ID value. You can plug in these numbers or this quadratic equation in your calculator and find the ID value. Since there are two variables or second order system, you will end up with 2 values. So I end up with ID equal to either 4 milliampere or ID equal to 1 milliampere. So we need to find out which one is the right current. So here I'm choosing ID equal to 4 milliampere. Okay, I'm choosing ID equal to 4 milliampere. I'm going to verify whether that current is right or wrong. So if ID equal to 4 milliampere, what is VS? Vs is nothing but 4 milli times 2, that must be 8 volts. Okay, then Vs equal to 8 volts. How about Vd? Vd must be, we just found this current is 4 milliampere. So 4 times 4, that's 16 volts. The voltage drop must be 16 volts here. 10 minus 16, your Vd equal to minus 6 volt. Okay, so what do you have? VDS. VDS must be minus 6 minus 8, so minus 14 volts. So if your VDS is minus 14, then according to this, your VDS, so if VDS is negative, that means your VD is negative value, than the VS, right? Here you're saying this is minus 6 volt, the VS is 8 volt, so current always flows from higher potential to lower potential. This current must flow in the opposite direction. For N-channel MOSFET, it always flows from drain to source, not source to drain. So what I'm saying, since VD is lower than VS, this may not be the right value. So this may not be right. Now we'll take ID equal to 1 milliampere. If I take ID equal to 1 milliampere, then Vs equal to, so the voltage here must be, let me change the color. Okay, so here my Vs equal to 1 milli times 2 kilo, so that's a 2 volts. So my Vs equal to 2 volt. Now Vd must be, so I'm taking this as 1 milliampere, so 1 milli times 4k, so that's a 4 volt drop. So 10 minus 4, this must be positive 6 volt. So Vd must be positive 6 volt. Okay. So Vs is 2 volt, Vd is 6 volt. So I can see that VDS is 6 minus 2, 4 volt. So definitely there will be some current passing through drain to source. Another way of verifying this must be VGD must be less than or equal to VT. VT, he gave us 1 volt. Okay, now we'll find the VGD. So I have VG is 5 volts, this is 5 volt, and VD 6 volt. So VGD must be VG minus VD. I have this is 5 volt and VD as 6 volt. So that's a negative 1 volt. Since VGD is less than VT, we're good. This is in saturation mode of operation. Okay, I will stop this example here. On the next video, we'll solve another example. Thank you.